Hello again, everybody. This is the notes for section 13.6. We are talking about the inverse trigonometric functions. So we've talked about them just a tiny little bit in the right triangle. You use the inverse trig function to figure out the angle measurement if you know the ratio. And we're still doing that, but we're going to go beyond the right triangle. So in this section, there's really two questions, and you see them here. Okay. First question, find all possible values for each expression. Okay, there are going to be an infinite number of answers, and I'll talk about what that means. But the problems are going to be something like this. Theta equals that inverse sine of square root 2 over 2, or whatever the ratio is going to be. More often than not, it's going to be those numbers that you see on the unit circle. So you're definitely going to want to have that out as we go through some of this stuff. In the second type of question, number 2, is very similar, but it says evaluate each expression. Now, there's a very subtle difference here, but the subtle difference means a big thing, a big deal. Okay, with this type of question, there's only going to be one answer, and what you're looking at is this, that capital S. Notice how it wasn't there in that example in the first question. Okay, the capital S is its specific notation. It means you're dealing with restricted numbers, and so you're only going to get one answer. Now, this is the way you're going to see it most of the time in the textbook. It's very common to see it looking like this, arc sign. It basically means the same thing, but still, restricted answer. So there's only going to be one. All right, so this is what we're dealing with for this section. So it says find all possible values for each expression. Trying to get rid of that box. There we go. Okay. Find all possible values for each expression. So notice no capital letter there. So we're talking about an infinite number of answers. So to get your answer, you're going to be using the unit circle. Now, remember on the unit circle, cosine of an angle was their x-coordinate, sine of an angle was the y-coordinate. So when I see these problems, I kind of turn the question around. Okay, our answer to an inverse trig function, it is an angle measurement. It helps me to think about this a little bit different. I'm going to change this expression to be the sine of theta equals a negative square root 3 over 2. So the answer I'm looking for is a theta value. Which angle, when I take the sine of it, gives me a negative square root 3 over 2. So looking around, again, it's sine. We're looking at the y values. So I'm looking for a y value to be negative square root 3 over 2. I see one right here at that angle measurement, and I see one down here. Now, there is a little trick. Okay, again, we're dealing with an infinite number of answers for these problems. Because the sine is the y value, what we're going to be doing is putting a horizontal line. You find your first value. Because it's the sine function, and because the sine function is the y value in the unit circle, draw a horizontal line through that first angle you find, and that's going to take you right to the other answer, the other angle. Now, notice how there's no angles on this. I wanted a clear center so I could draw these horizontal lines. This angle here, well, here's 270 on the negative y-axis, so that's a 30-degree angle. We're looking at 240 degrees here, and we go another 30, we're looking at 300 degrees here. You have your unit circle, so you'll be able to see those numbers, but that's what our answers are. So, one answer for theta is 240 degrees. The other answer for theta, when we take the sine of 240 degrees, we get negative square root 3 over 2. When we take the sine of 300 degrees, we get negative square root 3 over 2. But you got to remember, the sine function, it has a period of 360 degrees. So every time we go around the circle and we hit those angle measurements, those spots, we get another value, another angle that when you take the sine of it gives you the negative square root 3 over 2. So every time you go around the circle, so every 360 degrees, how we do that is by writing this. 240 degrees plus 360n. n is just an integer. So if n is 1, we go around the circle one more time back to the 240 spot. When n is 2, we're going around twice back to that 240 degree spot. Same thing with a 300 degree. 300 plus 360n. That is an infinite number of answers. Any one of those angles, you take the sine of it, you get negative square root 3 over 2. So we're just using our unit circle essentially. Okay, we're looking for in this problem, the negative square root 3 over 2. Because it's the inverse sine, we're looking at the y value to be negative square root 3 over 2. There's our two main answers. Add the 360n to both of them. Okay, so let's try this one. It says find all possible values for each expression. So now we're talking about the inverse cosine of square root 2 over 2. So again, our answer is going to be an angle measurement. It helps me to think of it this way. The cosine of what angle equals square root 2 over 2? So once again, unit circle. Cosine of an angle is the x-coordinate. So I'm looking for an x-coordinate to be square root 2 over 2. That happens right here at this angle measurement. Now, again, cosine is the x value. To find the other angle, where the cosine of that angle equals square root 2 over 2, what I'm going to do is, once I find that first angle, I'm going to draw a vertical line. You look at this point, right here. The cosine of that angle is the x-coordinate. It's also square root 2 over 2. So, when we're dealing with the inverse cosine, it's an x-coordinate. The cosine is an x-coordinate, so we're going to draw a vertical line, and that's going to give us our other angle. Okay, with the sine, it was the horizontal line to give us the other angle. So now, again, you'll see this on a unit circle. What we have here is 45 degrees. What we have here is 315. So the answer for theta, 45 degrees plus every time we go around, 360n. The other answer is at 315 plus the 360n for every time we go around. There is our infinite number of answers. Okay, for the tangent, again, same thought process for me. Tangent of what angle equals, oops, sorry, not -1, +1. Now, the unit circle doesn't really give us the tangent values. So, I told you before, as you figure them out, try to write them in so you have it as a quick reference for later on. Hopefully you did that because it's going to help a lot with this stuff. But the tangent of an angle is always the opposite over adjacent. And I've talked about this before also. The opposite side was our sine of an angle, and the adjacent side was our cosine of an angle. That was the y over x. So, in order to get this to equal 1, our sine and cosine values have to be exactly the same. That happens here. And it also happens down here in that third quadrant. We're looking for the x and y's to be the same for the tangent to equal 1. So, that horizontal and vertical line that worked for the sine and cosine, you have something similar. What you're going to do is, you're going to draw a line. You got to find that first value. But once you find that first angle, draw a line from, let's see, first theta value through the origin. So basically, you're drawing a diameter of the unit circle. Takes you right through that other angle. It will always work that way. So this angle here, once again, it's a 45-degree angle. Down here, this is 225. Now, we're dealing with a tangent function. Okay, from the last section, the period of the tangent function, that was 180 degrees. So, our answer, 45 degrees plus 180n. Every time you go another 180 degrees, you're going right back to another angle where the tangent will equal 1. And now technically, 225 plus another 180. But hopefully you notice something here. If you take 45 and add 180, you're at 225. If you're at 225 and you add 180, it puts you right back up to this spot where the 45 is. So technically these are both good, but there's a way to combine them. And it's really just the first statement. You do 45 plus 180n, you're going to hit that 225 position every time you increase n. So I'd accept either one of these. It's really cool if you can put this and see the relationship between these two individual answers and put the single one, but I'll take either one of those because they're both correct. All right, that's the first video. That's the first set of questions that I talked about here. That was just number one, where you're going to have an infinite number of answers. That's your thought process. Second video, we'll talk about question number 2.